day everyone, I am Germo de la Paz and welcome to my science class. This session is all about subatomic particles of an atom. Our learning objective for today is to determine the number of proton, electron, and neutron in a particular atom. Specifically, you are expected to differentiate atoms from molecules, discuss the historical background of the atom and subatomic particles, and describe atom and its subatomic particles. I would like to run through our session for today. First is its history. We will be discussing the history of the atom and the other persons involved in developing our understanding about the atom, followed by the subatomic particles of an atom. I'll be showing to you the different parts, subatomic particles of an atom. Afterwards, we will be differentiating neutral and charged atoms. We will be talking about the conditions to determine if a given atom is neutral or charged. And of course, at the end of our session, I'll be giving you a short assessment to determine if we were able to achieve our learning goals. Its history. The word atom derived from the Greek word atomos. It was given birth by these two bright minds, Leucippus and Democritus. By the way, Leucippus was the teacher of this young and bright student named Democritus. And they are talking about atom. The story goes like this. Democritus has been asking his teacher about subdividing a material. Democritus asked, "Shall we come up to the point that we can no longer divide a given material?" Leucippus thought about it and discussed it with Democritus. Let's put this into perspective. For example, I have here a piece of paper. May I ask you, how many times do you think I can fold it until such time I can no longer fold it? Probably you say 4, 5, 6. Let's find out. Let me fold this paper until such time I can no longer fold it. First fold. Second fold. Third fold. Fourth. At this moment, the paper is now hard to fold, but let me try if I can still fold it on the fifth time. Okay, I think I am able to fold it on the fifth time. On the sixth, probably I can still fold it, but on the seventh, I can no longer fold it. So therefore, I can fold this paper 6 times, and I came to the point that I can no longer fold it. That's how Leucippus and Democritus thought about this word atomos. You will come up to a point that you can no longer divide a matter, and that's what they call it, atomos. Atom is the smallest particle of a matter that is indivisible and indestructible. Indivisible meaning you can no longer divide it anymore and you cannot disrupt it to make smaller parts. That is what an atom is. Atom on your left side is described by having this only one and unique type of element or atom, while molecule is made up of 2 or more atoms. Like what you are seeing on the screen, atom is only made up of one single type, unique type of atom, while molecule is the combination of two or more atoms. Here are the different models of atoms. Since atoms are the smallest part of a given matter, no one has seen it because they are too small to be seen by our naked eye. We are about to use highly sophisticated microscope just to see the surface of the atom. On the previous and earlier times, they don't have such materials. But the minds of our scientists are very good that they were able to visualize how an atom looks like based on their experiments, based on their theories and observations. Let us discuss the different models proposed by these scientists. The first model was proposed by John Dalton, and we called it Dalton's atomic model. This initiative of John Dalton to describe, to visualize, and represent an atom inspired other scientists to create their own model based on existing facts and theory. Dalton's atomic model was the first complete attempt to describe all matter in terms of atoms and their properties. Dalton's atomic model is also known as the billiard ball model. As you can see in our illustration, his model just like a billiard ball model. Dalton imagined that an atom must look like this. According to John Dalton, a model should be hard, dense, a ball-like structure like a billiard ball. The concept of atomic nucleus and electrons were unknown during this time. That is why Dalton just imagined an atom like a billiard ball model, as simple as this, because during this time we were not able, they don't have the idea yet about the existence of these subatomic particles. But like what I said, because of Dalton's initiative to describe and represent the atom, we were able to come up with a very comprehensive understanding of what an atom looks like. John Dalton is an English chemist. He suggested that each chemical element consists of its own unique kind of atom, which is universally accepted by all scientists, and it is already proven that indeed a single type of atom is made up of its unique kind of atom. Here are the different postulates of Dalton's atomic theory. He was the mind behind Dalton's atomic theory. First, he postulated that all matter is made up of tiny, indivisible particles called atoms. Followed by, he postulated that all atoms of a specific element are identical in mass, in size, and other properties. However, atoms of different elements exhibit different properties and vary in mass and size. For example, hydrogen atom is identical in mass, in size, and other properties with another hydrogen atom. However, hydrogen atom has different properties compared to helium atom. The third one is atoms can neither be created nor destroyed. Furthermore, atoms cannot be divided into smaller particles. This principle help us understand the conservation of matter. You cannot create it, you cannot destroy it, furthermore, you cannot divide it to make simple particles. Fourth, atoms of different elements can be combined with each other in fixed whole number ratios in order to form compounds. For example, sodium atom can be combined with chlorine atom. Once chemical reaction is observed between these two different elements, they form new product called sodium chloride. These elements, they are different, but we can combine them with each other in fixed whole number ratios. And sodium chloride is an example of compound. Fifth and the last is atoms can be rearranged, combined or separated in chemical reactions. The only means that we can do such a rearrangement and combination or separation of this atom is through chemical reaction. Hydrogen atom with oxygen atom is what we call water, H2O. But because of Dalton's atomic theory, we were able to rearrange this one and form another compound due to chemical reactions. The second model I would like to introduce to you is the plum pudding model or the raisin bread method. This model was soon proposed after the discovery of electrons in 1904, but before the discovery of the atomic nucleus. So therefore, during the proposal of this kind of model, the proponent has already the idea about the electrons, but he doesn't know yet about the nucleus. Based on his model, he visualized an atom as an atom that has a negatively charged particles, which he compared to the raisins, embedded within and randomly in the cloud positively charged spheres, which he called the bread. So imagine a bread with a raisin or with raisins with pasas. These pasas or raisins were randomly embedded by the baker. There is no specific arrangement of these raisins in the dough, which the proponent thought as the positively charged spheres. So basically, this plum pudding model or the raisin bread model visualizes a type of atom that has a negatively charged particles randomly embedded or arranged in a cloud of positively charged spheres, which is what we call the bread. This model tries to explain that electrons are negatively charged particles and the atoms have no net electric charge. The positively charged sphere exerts the force on the negatively charged electrons, and the direction of the force is towards the center of the sphere. These negatively charged electrons repel each other and form the shells. The repulsion of the electrons is due to their charge. We know that both are similar charge repel, while same opposite charges attract. This plum pudding model was proposed by no other than Joseph J Thompson. He is an English physicist and he discovered the electron in the year 1987 using cathode ray tubes. While visualizing an atom that looks like a plum pudding model, he was able to discover electron, which will be part of the subatomic particles of an atom. However, there are limitations of J Thompson's atomic model, and here are these limitations. Thomson's atomic model failed to explain Rutherford's alpha particle scattering experiment, in which most of the fast-moving alpha particles went through the gold fold straight away. This alpha particle scattering experiment was performed by Rutherford, and it discovered one of the most essential subatomic particles of an atom. During J Thompson's visualization and representation of an atom, there is no subatomic particles aside from electrons. So because of Rutherford's alpha particle scattering experiment, J Thompson's atomic model failed to give us a very comprehensive characteristics of an atom. Aside from that, only some of the clearly defined atoms had much empty space, and the positive charge within the atom is concentrated in a very small volume. This is the drawback of Thomson's atomic model. He was not able to visualize that an atom must be made up of largely space. Similar to a plum pudding model, once the baker is molding the dough, there are no spaces inside of it, inside the bread. The third model is Rutherford's atomic model. This is what we call the alpha scattering experiment performed by Rutherford. This alpha particle scattering experiment proved that aside from electrons, there is also another part or subatomic particles of an atom, which he called the nucleus. On letter A, you can see that the thin gold foil is placed before the alpha particle emitter. This alpha particle emitter emits a number of alpha particles to hit the gold foil. He found out that most of the alpha particles from the alpha particle emitter pass through straight forward the gold foil. And Rutherford thought that there must be space among atoms. On letter B, you can see that the plum pudding model of J Thompson. On the lower part is the Rutherford's atomic model. Rutherford's atomic model is an improved version of a plum pudding model. As you can see here on the upper right, the electrons are randomly embedded, and the alpha particles must pass through the J Thompson's atomic model. But because of Rutherford's alpha particle experiment, he found out that some of the alpha particles bounced back, changed in direction, or were deflected at a certain angle. So therefore, Rutherford thought that there must be something that changing the direction of the alpha particles, which eventually he called the nucleus. The presence of the nucleus in Rutherford's atomic model is its prominent characteristic based on the result of the alpha scattering experiment. This revolutionary discovery of Rutherford helped us further understand the nature of an atom. Rutherford concluded that major space in an atom is empty, like what you can see on our illustration. And that is based on his observations during the experiment. In this alpha scattering experiment, a large fraction of particles pass through the world without being deflected. So therefore, there must be large space among them. This atomic model was proposed by Ernest Ford. He was a New Zealand-born physicist in 1911. The Rutherford atomic theory has defined the atom as a tiny, dense, positively charged core called a nucleus, which is surrounded by negative charges called electrons. Unlike plum pudding model, the electrons are embedded randomly. But in Rutherford's atomic model, it must be surrounding. It must surround. It must revolve. It must move around the center, which he called the nucleus. Here are the different limitations of Rutherford's atomic model. First, Rutherford's model was unable to explain the atomic stability. Atoms are stable at a certain point, but it failed to explain the atomic stability. Second, according to Rutherford's postulate, electrons revolve at a very high speed in a fixed orbit around the atom's nucleus. On the other hand, Maxwell explained that accelerated charged particles emit electromagnetic radiations. As a result, electrons revolving around the nucleus also emit electromagnetic radiation. Rutherford's theory was lacking in detail because it did not address the arrangement of electrons in the orbit. He explained that the electrons are moving around the nucleus, but he didn't specifically arrange these electrons in specific shell or orbit. The fourth model is Bohr's atomic model. This is the planetary model of an atom. As you can see, there are orbits. There are number of electrons. A photon is emitted with energy. This planetary model of atom is composed of small nucleus surrounded by negative electrons moving around the nucleus in a specific orbit. This observation representation is similar to Rutherford's atomic model. It is just Bohr's atomic model explained that aside from the electrons revolving around the nucleus, they are found in a specific orbit. This model explains that electrons are moving in a fixed orbitals or shells and not anywhere in between, unlike the Planck pudding model. As you can recall, the Planck pudding model, it shows that the electrons are randomly embedded in the positively charged cloud, which he called the breath. It also explains that each orbit or shell has a fixed energy. In our illustration, you can see that there are three shells or orbit. Bohr's atomic model says that it has fixed energy. The electrons that are found away from the nucleus have more energy, and the electrons closer to the nucleus have less energy. Based in our illustration, electrons found on the third shell or the third orbit, the electrons on the third orbit have more energy than to the electrons closest to the nucleus. This planetary model is proposed by Niels Bohr in 1915. He modified Rutherford's model of an atom. He actually adopted the idea that an atom must compose of a heart-dense, tiny, cold nucleus, and even improved the understanding of the electrons, that these electrons must be found in a specific orbit, unlike the Planck pudding model. Here are the limitations of Bohr's atomic model. First, Bohr's model of an atom failed to explain the Zeeman effect. Zeeman effect is the magnetic field, the effect of the magnetic field on the spectra of atoms. Second, it also failed to explain the Stark effect, the effect of electric field this time on the spectra of atoms. Third, it violates the Heisenberg uncertainty principle that will be discussed later. Fourth, it could not explain the spectra obtained from a larger atom. The last model is Schrödinger's atomic model. As you can see, it looks like a fuzzy model. This is the quantum mechanical atomic model. The inspiration of this model was Bohr's atomic model. This atomic model of Schrödinger is based on the principle of quantum mechanics. Quantum mechanics is a fundamental theory in physics that explains the physical properties of nature in the scale of atoms and subatomic particles. One thing that is good in Schrödinger atom is that it assumes that the electrons is a wave that tries to describe the regions in space or orbitals where electrons are most likely to be found. We know that electrons are found orbiting the nucleus, but Schrödinger even further studied the location where likely the electrons to be found. This model was used to calculate a mathematical equation that discovered the electron occurring in different places or in a certain position. It doesn't specifically locate the place or movement of the path that the electrons in an atom go, but it gives us the statistics and the probability of an electron being at a certain position at a certain time. Electrons are very fast. They really move very fast, revolving around the nucleus. And we don't have the capability to predict specifically the location of the electron in a specific time in motion. But instead, we can have the probability of finding the electron at a certain point at a certain time. Heisenberg developed the uncertainty principle that explains the position and the velocity of an object cannot be measured exactly at the same time. That is why we can only predict, we can only have the position of a given electron with high level of uncertainty. This model was proposed by Erwin Scottinger, born in August 12, 1887, and he won Nobel Prize in Physics for his discovery and his atomic model. Here are the different limitations of Schrödinger's atomic model. First, this model is made up of mathematical equations known as the wave functions that satisfy the requirements placed on the behavior of electrons. Since Schrödinger used mathematical equations to describe an atom, that is an advantage. However, this mathematical operation is unfamiliar and it is too difficult to imagine a physical model of electrons as a wave. We are done with the history of discovering the atom. Let's talk about the subatomic particles of an atom. We are so thankful to those scientists because they paved the way for us to understand the nature and the subatomic particles of the atom. Here is a quantum mechanical model of an atom. As you can see, the electrons are revolving around the nucleus in specific orbit or shell. And at the middle is the nucleus. The nucleus is further made up of two subatomic particles, which are the protons and the neutrons. Let's talk about electrons. Again, electrons are revolving around the nucleus in specific path. And there is a certain number of electrons in each specific orbital shell. Electrons are found outside the nucleus. They are negatively charged subatomic particles of an atom. These electrons can be given off or shared during chemical reaction. The second subatomic particle is the proton. Proton is found inside the nucleus of the atom. It is the positively charged subatomic particle of an atom. The third is the neutron. Together with the proton, neutron is also found inside the nucleus. Neutron, unlike proton and electron, has no charge. Neutron and proton are found inside the nucleus. And based on study, the nucleus of an atom is the part of an atom where most of the mass of the given atom is concentrated. So therefore, the mass of an atom solely depends on the mass of the proton and the neutrons. Electrons have also mass. It is just the mass of an electron is almost negligible. The next part is the orbit or the shell. That is where we can find electrons. That is where most likely electrons are to be found. Those are the subatomic particles of an atom. Here we have to differentiate neutral atom and charged atom. When is the time that an atom is neutral? Neutral atoms are said to be neutral if they contain the same number of protons and number of electrons. To determine if the given atom is neutral, all you have to ask yourself is the number of protons the same as the number of electrons? If your answer is yes, then most likely that is a neutral atom. On the right side, you can see the notation that will tell us about the properties of the given atom. X stands for the symbol of the element. A stands for the atomic number, while the lower part is the atomic mass. These notations will be useful to you to our next session. Charged atom can be considered or classified or identified once they have electrical charges. And to become charged, an atom should either give off or receive certain number of electrons. Once an atom becomes charged, once an atom released or gained electrons, they are now considered or called ions. And ions are electrically charged particles. There are two charges or two types of ions. First is the cation. Cations are charged atoms. Cations are positive ions. So therefore, it has a charge of positive. Cation can lose one or more electrons. Since we know that an atom becomes cation once it loses one or more electrons. If cation can lose one or more electron, then therefore, the number of protons is now greater than the number of its electrons. The second type of ion is what we call an anion. These are charged atoms. And ions are negative ions. If cation releases certain number of electrons, an ion can gain one or more electrons. Since an ion receives or gains certain number of electrons, the number of protons is now less than the number of his electrons. So there you have it. Those are the different properties of an atom. For this moment, let me give you an assessment to determine if you were able to achieve our learning objectives for today. All you have to do is to contact me, send an email or message to my messenger giving me a notification that you are done with this session. I'll be waiting for your notification so that I can give you the link of your assessment. Congratulations everyone for having this session entitled Subatomic Particles of an Atom. For our next session, we will be having a lot of discussions about determining the number of subatomic particles in a charged and neutral atom. Again, I am Jamal de la Paz and see you again in my science class.